In this first problem, we have a car that's driving east and then south. So if we first draw the triangle to represent the motion, we have east and, sorry, that's the wrong direction. So we have the vehicle starting here and driving east. So this is A to B, and then from B to C, they're going south. And we're asked to figure out the average velocity in terms of the magnitude and the direction. So if I just draw my values onto the triangle, here I have 150 kilometers east. That happens in 45 minutes or 3/4 of an hour. And then from B to C, they travel 300 kilometers, and that's in 1.5 hours. So to figure out A to C, we just use the Pythagorean theorem. And this comes out to 335 kilometers. To figure out the total time, I just take the 3/4 of an hour plus an hour and a half. This gives me 2.25 hours for the whole trip. And to figure out the average velocity, at least the magnitude of it, we take the total distance and divide that by the amount of time. And we find that the car was traveling 149 kilometers per hour. Now for the direction, I'm really looking for the angle here. So for that angle, I would need to use the tangent function, because I really should use values that I already have. So the ones that I started with of 150 kilometers, that's the adjacent value, and 300 kilometers is the opposite value. So I have 300 kilometers over 150 kilometers. This would rearrange to theta equals the inverse of tangent times that same value. And this comes out to approximately 63 degrees. So the answer would be that the average velocity is equal to 149 kilometers per hour at 63 degrees, and this would be southeast because the car traveled east and then south. So southeast or south of east, doesn't matter. For problem number 2, this is a ball kicked horizontally at 8 meters per second from a cliff. If I draw the cliff here, the ball was here, and the ball was kicked horizontally and would have fallen that way. So we're asked to find how far from the base will the ball land. So since this is just horizontal motion, I'm using the equation that's outlined in red on our equation list. And I can plug in the values. If you're still using the chart, that's fine. You could just write in the values that you have or that you need to find. So I know that I don't have time yet. But if I just write out the equation as it is, I'll eventually get to the point where I don't have time to fill in. So the initial X location would have been 0 meters. And I'm told that the initial velocity in the horizontal direction is 8 meters per second, and I don't have time, so I'll just leave that blank. So to find time, I kind of stick with the same equation every time that I need to figure out TF or T sub F, because it doesn't really have many squares, and I don't have to really use trig to find any of the values. This, I think, is the yellow equation on the sheet or on the slide. So I always subtract the initial y from the final value of y, because that's basically the change in y. And then from that point, the initial velocity in the y direction was 0. So since this is 0, this whole thing cancels out, and I'm left with 1/2 of like the acceleration in the y direction, which is going to be 9.81 meters per second squared. And then I have the final time. Actually, I think I've made a mistake here. I just forgot a square. The square goes here. Okay, so from this point, I have the change in y is negative 80 meters because the cliff is 80 meters tall. So I have negative 80 equals 1/2 times negative 9.81 meters per second squared, and then the final time squared. And this will rearrange so that I have negative 80 meters divided by 1/2 of negative 9.81 meters per second squared. And I have to find the square root of that to find final time. That gives me that the final time is equal to 4 seconds. So if I take that and plug it into my equation up here, I find that the final location of x is 8 times 4, which is 32 meters. Okay, so at this point, I would like you to try the remaining problems 3 and 4, and I'll post the video for those later.